Graphing radical functions notes. Starting off with y equals the square root of x. This is our parent function. Okay, so starting off graphing this, let's start with an input value of 0. Square root of 0 is 0. Okay, going down our input line, our next input value is 1. The square root of 1 is 1. So when we input 1, we get 1 out. 2, the square root of 2. Let's go ahead and skip that one. Square root of 3, that's irrational. Square root of 4, output is 2. The next perfect square is 9. The square root of 9, plugging 9 in, we get 3. 1, 2, 3. And this is our parent function for our square root function. Okay, domain is your x values. Remember, we do left to right, so our leftmost x value is 0. Our rightmost x value is an arrow, which represents infinity. It goes on infinitely. Range value starting off with 0 again. Lowest to highest. Highest is an arrow, so we go to infinity. Okay, changing colors. Here we have 2 times the square root of x. And all that means is we're going to do the same process, except we're going to multiply each output times 2. So when we plug 0 in, we get an output of 0 times 2 is also 0. 1, square root of 1 is 1. 1 times 2 is 2. So our output is 2. Okay, next perfect square is 4. Square root of 4 is 2. 2 times 2 is 4. So notice our outputs are doubling. So if our input was 9, we got the square root of 9, which is 3, and then we double 3, we get 6. So 3, 4, 5, 6. And this is our graph. Okay, domain still starts at 0 and goes to infinity. Range has not changed either. Still starts at 0 and goes to infinity. Okay, next one. This time, same process. Plug in our input value. This time we're multiplying by -1. So 0, square root of 0 is 0, times -1 is still 0, so we stay at 0. Next input value is 1, square root of 1 is 1. 1 times -1 is -1, so instead of going up 1, we're going down 1. Okay, square root of 4 is 2. 2 times -1, -2. Next perfect square is 9, and we're going to go down 3. Alright, domain's the same. It still starts at 0 and goes to the right infinitely. Range is going to be different. Lowest to highest. Lowest is an arrow, so we're going to start off with -infinity. And the highest is 0. -infinity to 0 on the y-axis. Moving along. Alright, now we have a shift. We have x plus 4. Let's take a look at that. What will make this 0? What value of x will make this 0? Correct, -4. So -4 is where we're going to start for our input. So plugging -4 in, we get -4 plus 4, which is 0. Square root of 0 is 0. So at -4, our output is 0. Now, we can use this pattern for our square root functions. So from that starting point, if we go over 1, up 1, unless there's a stretch or a compression. So we could do that here. From here, we could go over 1 and up 1 for our next point. But let's just test it. Negative 3. Negative 3 plus 4 is 1. Square root of 1 is 1. So when our input is negative 3, our output is 1. Again, look at our pattern. The next one is over 1, 2, 3, 4. 4, 2. So from this point, we could go over 1, 2, 3, 4, 1, 2 to get our next point. But let's see if that works. So if I input 0, 0 plus 4 is 4. Square root of 4 is 2. So 0, 2. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3. 1, 2, 3. Alright, so our domain is going to start at negative 4 and go to infinity. Okay, you complete the range on that one. Let's go to the next one. The next one, we have the square root of x plus 4. So since the 4 is on the outside, this is a shift up 4 units. So starting at 0, if I plug 0 in, the square root of 0 is 0 plus 4, which is 4. So when we input a 0, our output is 4. Now let's follow that pattern. So from this point, we go over 1, up 1 to get our first point. Over how many? That's right. 1, 2, 3, 4. How many up? 2, because the square root of 4 is 2. Okay. 5, 6, 7, 8, 9. Next perfect square, 1, 2, 3. And we get our graph. I'm going to let you go ahead and do the domain and range on that one. Alright, here we have, what do you think? 3 units to the right, 5 units down, correct. So 3 to the right, 1, 2, 3, 5 units down, 1, 2, 3, 4, 5. So again, once you find that starting point, you can just go ahead and follow that pattern we've been talking about. So how many units over? 1. How many units up? 1. What's the next perfect square? 4. 1, 2, 3, 4. 1, 2. That should do it for that one. And you can go ahead and do the domain and range on that one as well. Alright, let's go to the back. What trends or rules can you determine based on these graphs? I'm going to go ahead and let you fill that in. Hopefully you remember these from working with quadratics, what they do, which variables control the domain, which of the above variables control the range. I'm going to go ahead and let you answer those 2 questions. Alright, let's do one of these together. It says graph and describe the translation from the parent function y equals the square root of x. Alright, how many transformations do you see here? You should see 3. First, we need to start with inside the grouping symbol. The square root is a grouping symbol. This says to move 8 units to the left, 2 units down. So 8 to the left, 2 down. Now there's one more thing. We have a reflection. Remember, when you have a negative, that means, negative means multiply by negative 1. Multiply by negative 1. So once we find a starting point and we follow our pattern, remember we go over 1, our pattern is to go up 1. But because of the negative 1, instead of up 1, what's 1 times negative 1? Negative 1, correct. So instead of going up 1, we go down 1. Okay, next perfect square. 1, 2, 3, 4. Square root of 4 is 2, but 2 times negative 1? Negative 2. 5, 6. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. Square root of 9 is 3, but 3 times negative 1? Negative 3. Okay, so we have our graph. Oops, missed that last point. Oh well, close enough. Okay, so let's go ahead and do the domain on this one. Remember, domain is from the left to the right. And our leftmost point here is at negative 8. And our rightmost point is an arrow. So we go to infinity. Our range is lowest to highest. Lowest point is an arrow, so we're at negative infinity on the low end. On the high end, it stops right here. So we go over, that's going to be negative 2. All right, translations. Well, obviously there's two translations. It moved 8 units to the left, 8 units left. Okay, and 2 units down. Now, this next one is not a translation, it is a transformation. And what does the negative do to the graph as you think about what happened to it? It got flipped upside down. And what do we call that? We call that a reflection over the x-axis. Alright, so you go ahead and do this one yourself, and I will be checking this work tomorrow when you come into class. Thank you.